If you've designed any electronics, you must have run into this situation. You design something and calculate a resistance that you need for your circuit, but it's almost never going to match one of the resistors you have lying around, or any standard resistor value. The question is, what is the minimum number of standard resistors to create the resistance you need, or what's the best way to get that resistance with the resistors you already have lying around? I'm going to show you a really easy way to optimally design your circuit to get the resistance you need within your required tolerance. This is a slightly artificial example, but let's say I'm making a tone generator for the musical note A, which is 440 Hz, using a 555 oscillator. I have a capacitor of 1 microfarad. I need to calculate the resistance to get 440 Hz. We know the formula to calculate the frequency of the oscillator, so it can be rearranged to calculate the resistance instead. Putting in 440 Hz and 1 microfarad gives a resistance of 1639.4 ohms. The closest common standard resistors are 1.5K and 1.8K, but using 1.5K would give a frequency of 480 Hz, and using 1.8K would give a frequency of 400 Hz. Both are more than a semitone out of tune, so let's do better and calculate a resistor network to give the correct resistance. To do that, we'll use a circuit design feature in the free Hammond-Moore app. I'm using the Linux version here, but it's available on other platforms too, including mobile. From Reference, choose Electrical and Resistance Builder. The first thing is to select which resistors you have available for the design. You can choose from sets of standard resistor values or enter your own values from the parts you have available. For this example, let's say I have some common resistors, and if I have some extras lying around, I can enter those too. Say I want to be within 1 Hz of 440 Hz, then I need a resistor between 1635.7 and 1643.2 ohms, or in other words, 1639.4 ohms with a tolerance of better than 0.23%. So I enter the ideal 1639.4 ohms and tap Solve. The first solution is a single resistor, and the best possible is out by 8.5%. So I look at the next one. It's also too high, but the solution for 3 components is within 0.01%, which is very close. I can select it to see the circuit, which is a 1K resistor and 680 ohm resistor, all in parallel with a 68K resistor. Doing that manually would have been tricky. In practice, you'll find you never really need more than 3 or 4 resistors to get a suitable approximation, but you can solve up to 8 with the calculator if you have a very limited set of resistors available or some bizarre requirements. The thing is, solving for all possible arrangements of 5 resistors takes quite a lot of time, and solving for 6 and over takes basically forever. But the calculator searches the best choices first, so most likely it will find a good solution early and stop if it gets close enough before forever has passed. Say we choose 2345 ohms and up to 8 components with a limited set of resistors. You can see the various solutions progressing and the best it's found so far. At any point it's good enough, or if it's taking too long, you can click Stop and see the best solutions. For 5 components we have a very close solution, 2345, but actually 4 is about as good, and even 3 is almost exact. So there you go, a quick easy way to get the resistances you need. You can get the app Hammond-Moore from hammondmore.net. It's free.